Welcome to the 13th session on galvanic cells, which belongs to electrochemistry, and in this session we will be seeing electrochemical energy storage devices. So, before going into detail, I will just warm up on the topic galvanic cells, which we have seen a few classes in advance. Okay. So, what is a galvanic cell? Galvanic cell is a cell, it is also known as an electrochemical cell, in which there will be chemical energy stored, and this chemical energy you can convert that into electrical energy. Now, let us go into detail about the cell reactions happening. At anode, what will happen? Anode is a electrode at which oxidation takes place. Okay, oxidation takes place. So, suppose I am having a metal M. Okay. This metal gets oxidized to form Mn plus N electrons, where we assume the valency of metal to be N. Okay. Now, what happens is this metal ion goes into solution, while the electrons remain on this metal part. Okay. So, when the metal goes into the solution as metal ions, the electrons are left back, and these electrons, they remain on the metal part of the anode. Now, what happens is at anode there will be accumulation of electrons, while at cathode we have reduction taking place, where the metal with a valency N plus will take up N electrons and then reduces to the solid metal. Now, what happens is the Mn plus, here you will be having Mn plus, Mn plus in solution. This Mn plus takes up electrons, gets reduced and gets deposited on the metal part. Now, here at the metal part, it requires electrons for the Mn plus to get reduced, or at cathode you will have deficiency of electrons. Okay. But at the same time at anode what happens is the metal is getting oxidized, leaving back its electron on the metal part, and here we have excess of electrons. Okay. Now, what happens is if it is connected through an external circuit by a conducting wire, what happens is the electrons, you can see that electrons are flowing from the anode to the cathode, and therefore, anode will be negatively charged because there is an excess of electrons, and cathode will be positively charged. Now, this flow of electrons is responsible for the electric current flow, and the electric current is supposed to flow in the opposite direction. It is considered like that. Okay. So, one thing you should understand, anode is where oxidation takes place, and that will be rich in electrons, and that will be the negative terminal. At the same time, cathode will be deficient of electrons, and that will be acting as a positive terminal. Now, we are going to consider the galvanic cells alone in this session, and in galvanic cells how these electrical energy we can be derived, and we are going to consider the storage devices in which we can store this chemical energy, and whenever required you can tap that electrical energy. Okay. So, let us see what is the electrochemical energy storage devices you will be seeing in this session. We will be seeing batteries, we will be going through the types of batteries which are available now, and they are classified as primary and secondary batteries, and in secondary batteries we will be seeing about the lead acid battery and also a brief explanation of capacitors and super capacitors. Now, let us see first what are they. Electrochemical energy storage devices include batteries or cells. We call them as batteries or cells. The common nomenclature used for cells is batteries, where common men say that it is a battery, but in scientific terms we usually mention it as cells. Now, we have the electrochemical capacitors. This is a new advancement in which capacitors are used as electrical energy storage devices. Okay. Now, let us see what are batteries. Batteries are electrochemical cells itself. The name given is battery, but they are actually the electrochemical cells that convert stored chemical energy into electrical energy. So, they have got stored chemical energy and that can be converted into electrical energy whenever we require it. Now, batteries, they can be classified into two, mainly as primary battery and a secondary battery. So, two types of batteries, one is a primary one, the other one is known as a secondary battery. Now, let us see what do you mean by a primary battery or a primary cell or a secondary battery or a secondary cell. Primary battery or cell is any kind of battery in which the electrochemical reactions are not reversible. That is, there will be chemical reaction undergoing and this chemical energy is being converted into electrical energy, and this can never be reversed. That is, if you supply electric current to that, you cannot reverse this reaction and then again use it. So, they are irreversible electrochemical reactions, and therefore, they are not rechargeable. You cannot recharge it. Once it is lost, just throw it away. Okay. Examples are Daniel cell, which we have already seen in the previous sessions, dry battery, which we use in our remote controls, then wall clocks, etc. Mercury cells, they are the cells we use in watches, calculators, hearing aids, etc. And silver oxide or zinc oxide batteries, they are very rare, they are also used as mercury cells itself, but since of their high cost, they are not put into practice in many of the electrical appliances. Now, let us see what do you mean by a secondary battery or a secondary cell. Secondary battery or a secondary cell is also known as rechargeable battery because their electrochemical reactions are reversible. Because in these batteries, if you give a power from external circuit, the reactions can be reversed and they come back to the original condition from where you can again use it for tapping electrical energy from them. Okay. Such batteries are known as secondary batteries. Examples is a lithium ion battery. You might have heard about this, lithium batteries. Then lead acid batteries is the most old one, that is a lead acid battery. Then nickel cadmium batteries, all these come under this type of batteries. Now, there is another class that is known as capacitor. These capacitors, they are used to store electrical energy, because in most of the electronic circuits we have capacitors, but the thing is that when an electric current is passed, they store electrical energy in the form of a static energy. That is, you have the positive and the negative charges developed in them and they are separated, and whenever required you can tap this energy. Such a device is known as a capacitor. So, capacitor, it has two terminal passive circuit that can store electrical energy in the form of electrostatic charges, that is opposite charge, positive and negative charge. Okay. It consists of two metal plates, and in between two metal plates you will be having a dielectric material to prevent the discharge of the formed electrostatic charges. Okay. Now, in this case what happens is the energy stored is very low and the energy which we can tap out also will be very little. That is usually in the case of a capacitor, which we use in all our electric and electronic circuits. Okay. The common dielectric material used in a capacitor are ceramic polymers, mica, paper or aluminum oxide. These are the dielectric materials generally used in a capacitor. Now, we come to a new type of capacitor which is known as supercapacitor. Now, supercapacitor is also known as electrolytic capacitor. So, it means that it contains some electrolyte in that, in which it has two conducting metal plates. They are coated with activated carbon to make them more superconducting, and they are separated by an electrolyte solution instead of a dielectric material. So, here the difference is we have two metallic plates which are conducting and they are coated with activated carbon, but instead of a dielectric material, in this case we are using a electrolytic solution, and therefore, they are known as electrolytic capacitor. Now, here what happens is between this metal and the electrolyte, where there is a junction between these two where they become in contact, once the electric charge is applied, they get polarized and there develops a electrical double layer between at the interface of the metal surface and the electrolyte. Okay. And therefore, they are also known as electrical double layer capacitors too. Okay. So, this is a particular type of capacitor and they are known as supercapacitor because compared to the ordinary capacitor, they can store more amount of electric energy in the form of an electrostatic field. Okay. So, that is why they are known as supercapacitors, and supercapacitors are now used as instead of batteries, but they are not as efficient, but still a better source because they are cheaper and you can store energy to some extent in that and you can tap it in the form of electric energy, and more developments are going on. Further, you will be replacing batteries using supercapacitors. Now, let us go in detail of a primary battery. Primary battery, the first example is a dry cell and this is the first one discovered. Dry cells are the ordinary cells we have seen we will be using in the TV remotes, in some torches, in wall clocks and all. It is a common battery and it is one of the cheapest batteries. It is known as zinc carbon battery. It is also known as a zinc carbon battery. And here we have, this is developed from an old electrochemical cell named after Leclanché. It is known as Leclanché cell and it has been derived from that. Leclanché cell is a wet mode. In this case, we are using a somewhat dry mode of electrolyte. Okay. Now, in this battery, we have zinc as the anode and manganese dioxide as the cathode. So, zinc is the anode, manganese dioxide is a cathode. Zinc is the anode means that will be acting as the negative terminal and manganese dioxide will be acting as the positive terminal, and we have an electrolyte which is a mixture of ammonium chloride and zinc chloride. Okay. Now, here there is a picture cross section of a battery in which we have the negative terminal which will be a zinc metal. Positive terminal is usually a carbon rod because to conduct carbon in the sense it is graphite, the carbon rod that will be acting as the positive terminal which is in contact with. You can see that here we have the carbon and manganese dioxide mixture. Here manganese dioxide is acting as the cathode. Okay. And zinc, that is actually the vessel is made up of zinc, and within which you will be having this carbon rod at the center with the carbon and manganese dioxide as a mixture, and we have the electrolyte is given here, that is a mixture of ammonium chloride and zinc chloride. Okay, there is a airspace, and this is all regarding the design of that, and this will be the carbon rod which is a positive terminal, or you can say that this is the cathode. This is to derive electrons from this mixture of carbon and manganese dioxide. Here we have the vessel made of zinc, this will be the anode, and here the oxidation takes place, leaving back the electrons, and this acts as a negative terminal of the battery. Now, let us see what are the cell reactions taking place. At anode, zinc gets oxidized to zinc ions, releasing 2 electrons. Zinc gets oxidized. Okay. So, that is our oxidation. Here at cathode, manganese dioxide along with ammonium ions takes up electron and gets converted into hydrated manganese oxide, and ammonia gas is released. Now, here we will check what is happening with manganese dioxide. Manganese dioxide, oxygen has got an oxidation state of -1, and we have 2 oxygen atoms. So, that will be -2 into 2, that becomes -4, and therefore, manganese will be at the oxidation state of +4. When it goes over here, of course, oxygen will be having a -2 charge, while OH has got only -1 charge, and that means manganese will be offering a positive charge of +3. That means manganese goes from +4 state to +3 state, or you can say that manganese is getting reduced, that is manganese dioxide is getting reduced to form hydrated manganese oxide. So, this is the reaction taking place at the anode and the cathode. Next, we will go for the alkaline battery. This is also a primary cell. The alkaline batteries, they also have zinc and manganese oxide as an anode and cathode. Okay. But the only difference is the electrolyte is either potassium or sodium hydroxide. Sodium hydroxide and potassium hydroxide, we know that they are alkalis. It can be either sodium hydroxide or potassium hydroxide, both are alkalis, and therefore, the name alkaline batteries. But since the other case, that the dry cell, we were having a paste of ammonium chloride and zinc chloride as the electrolyte. Here we are having sodium hydroxide or potassium hydroxide as the electrolyte, but see the reaction at the anode and the cathode differs because the electrolytes are different. Okay. Now, one more point to be noted is these alkaline batteries compared to the zinc carbon batteries, they have more constant voltage and their energy density is higher compared to the zinc carbon batteries. So, you can have an alkaline battery to have a longer life compared to the zinc carbon battery. These also it is available in the market and we are using it. I do not refer the brand names, but you can see that it is written as alkaline batteries, and these batteries we consider zinc as the anode and manganese dioxide as the cathode. Now, let us go for the reactions at the electrodes. Zinc along with hydroxide ions gets converted into zinc oxide, water, and 2 electrons are released. At the cathode, manganese dioxide takes up electron in the presence of water and gets converted into manganese oxide, that is dimanganese trioxide, and OH minus ions are released. Now, in this case it is sure that zinc goes to +2 oxidation state, and therefore, you can say that it is an oxidation process, and in this case you can see that this oxygen -2 into 2, that becomes the total charge carried by oxygen is -4, and in this case it will be +4. Here we have 3 oxygen atoms, so that is -6, and 2 manganese together should be offering +6. That means each manganese ion goes to the +3 state. Again there is a reduction, that is one manganese ion in the +4 state goes to the +3 state, again that refers to a reduction. Next type of battery is the mercury battery, or we call it as a mercury cells. You have seen that in calculators and watches we are using this mercury batteries, and also in some hearing aids and some digital thermometers and all those things. Okay. So, mercury battery or mercury oxide battery is a primary, again this is a primary cell which is in the shape of a coin and is used in many electronic devices like calculators, watches, digital thermometers and hearing aids. See, just go through the picture, you will be familiar with this type of batteries. Now, we have given the cross section of this. Here in this type we have, in mercury cells you will have either zinc or cadmium as the anode, and the cathode will be mercuric oxide, that is mercury in the oxidation state of +2. Okay, that is mercuric oxide. Electrolyte is taken as a saturated separator. Here we have a separator, this is a separator which is saturated with the electrolyte. Okay, and that separates these two, that is on the one side we have the anode, the other side we have the cathode. Anode will be the negative terminal and cathode will be the positive terminal. Electrolyte is usually sodium hydroxide or potassium hydroxide. Here anode is, you can have either zinc or cadmium, but cathode is always mercuric oxide. The electrode reactions, that is usually zinc combining with hydroxyl ions to give zinc oxide plus water, and 2 electrons are given out. So, that is an oxidation process. At cathode, mercuric oxide takes up 2 electrons in the presence of water to give mercury and hydroxyl ions. Here zinc goes to +2 oxidation state. Here mercury, which is in the +2 oxidation state, goes to 0 oxidation state. So, that means there is a reduction. Now, the great advantage of mercury cells is that you can keep this batteries, mercury batteries, for a long period, and during this period neither the potential or the current density of the cell is not altered. While the other batteries which we had mentioned in the dry and alkaline batteries, we have a long period time we store it. What happens is its current density as well as the potential drops. So, this is the main advantage, and it is also leak proof, and therefore, we use it for most of the electronic equipments and all which requires a power supply. Okay. But though it has all these advantages, there is a very high threat of mercury poisoning. Once it is used, it is thrown out as a waste, and this causes mercury poisoning. This is a threat to environmental pollution causing heavy metal mercury. Okay. So, these are the 3 type of primary batteries we have seen. First one was the dry cell, second was alkaline batteries, and the third one is the mercury cells. Now, we are going to the secondary batteries. Secondary batteries, as I have mentioned earlier, it is a battery which can be used once and then recharged, and then again you can use that battery. But remember, once you use it and recharge it, do not think it is 100% reversible. To some extent the reversibility is not 100%, and after a long period even the secondary batteries become useless. Okay. Now, what happens when the charging of a battery and discharging of a battery occurs? Discharging is when we draw electricity from that, the battery is getting discharging. After discharging, you pass electric current and then recharge it. Okay. So, that is the words we will be using here. Now, during the working of a battery, as I have told you earlier, in a galvanic cell, what happens is electrons flow from anode to cathode. So, this flow goes on until there is a strong depletion of electrons at the anode, and there won't be a flow of electricity then. Okay. So, it runs out of electrons. Now, what we do is, since this process is reversible, we apply an external electric field and the whole process is being reversed. You can see that in this case electrons were flowing out. Now, we apply an external current and reverse the reactions. Okay. Here what happens is, here cations will be formed into the solution, electrons are flowing out. Here anions will be released as a result of cations getting deposited. Now, this process is reversed, the cations flow back, anions go back, and the cell is recharged and it is ready for the next chemical reaction taking place within it to release the electrical energy. So, that is what happens during this is discharge. Discharge means we are using, you are tapping electric energy from that, and this is when we charge the electrochemical cell, that is you are going to bring back all the reactions, though it is not 100% reversible, it is brought back and then the battery is ready for again use. So, first example we will be seeing is the lead acid battery. Lead acid battery is the oldest type of rechargeable battery because it is the cheapest one and it is widely used in most of the power storage systems. We are using lead acid batteries. Now, here anode will be lead, cathode will be lead dioxide or lead peroxide, as whatever you like to call it, and we have an electrolyte which is dilute sulfuric acid. Do not think it is a concentrated one, it is a dilute sulfuric acid. Now, I have the cross section of this battery. See, these black colored plates, they represent the lead anode, and the brown colored plates which represents the lead dioxide, which will be the cathode. Okay. And inside these are dipped in a solution of dilute sulfuric acid. So, that forms the electrolyte. Now, just note that the lead plates are connected together, you get one terminal. The lead dioxide plates are connected together, we have the cathodic terminal. And we know that anode will be the negative terminal and cathode will be the positive terminal. Now, let us see what is the reactions taking place within the cell. Here we have anode lead which will combine with sulfate ions derived from the sulfuric acid and gets converted into lead sulfate plus 2 electrons. And just note that here I have been using a reversible arrow to show that these reactions are reversible. Okay. Then at the cathode, lead dioxide combines with 2 electrons in the presence of sulfate and H plus ions. These sulfate and H plus ions are from sulfuric acid and gets converted into lead sulfate and water. Okay. Now, let us see, in this case it is very clear, sulfate has got an oxidation state of -2 and therefore, lead is oxidized to +2 oxidation state from 0 state. Okay. So, that is oxidation for sure. Now, in this case oxygen, one oxygen atom -2 and you have 2 and therefore, this is -4. So, lead will be in an oxidation state, that is a single lead atom is in oxidation state of +4. When it gets converted into lead sulfate has got a -2 oxidation state, lead sulfate anion, and here lead will be therefore in a +2 oxidation state. From +4, it is getting converted into an oxidation state of +2 where the lead is getting reduced, that is lead dioxide or lead peroxide is getting reduced. Okay. So, that is a cathodic reaction. Now, these reactions are reversible. These are the reaction when the battery is discharging. These are the reactions when battery is discharging. When we apply external circuit and provide electric energy into this. All these reactions get reversed, that is lead sulphate gets converted into lead dioxide, and similarly this lead sulphate also gets converted into lead. So, all these reaction gets reversed and then the cell is ready for functioning again, or you can say for discharging. So, on charging what happens? All these reactions are reversed. Okay. On charging, these reactions are reversed. Okay. So, you can use it again. Now, again one more point to be noted is that in this lead is being consumed as lead sulphate, and also sulfuric acid also is used up while these process, because it is used up to convert lead into lead sulphate. So, what will happen? Lead being consumed, sulfuric acid, what happens that during working of, that is during discharging or working of this battery, the density of sulfuric acid decreases. And then when you charge that, it is not 100%, all the lead sulphate does not get converted into lead, or all the lead sulphate does not get converted into lead dioxide to a 100% level, but to some extent there will be a loss. And that is why after certain years, that is you can keep a battery for nearly 4 to 5 years, and after that you will not be getting the same voltage and current density from that battery, because it keeps on decreasing, because 100% reversibility is not possible. Now, let us go for wind up the session. In the session, we have been dealing with types of batteries, that is primary batteries and secondary batteries. In primary batteries, we have been seeing zinc carbon battery, alkaline battery and mercury battery in detail. Among secondary batteries, we have been first how a battery works during charging and discharging, and also an example of detailed example of a lead acid battery. Thank you.